On this page here in our notes, we're going to talk today a little bit more about the sides of triangles. We spent some time now talking about like the angles and like what angles inside of an isosceles triangle do, and like being able to kind of still recognize those relationships like vertical angles, linear pairs, those kind of things start to still show up in those triangle problems. Now I want to talk a little bit more about the sides. We talked yesterday about isosceles triangles and like that their two sides are the same, two angles are the same, but I want to talk more like in the general sense of, are there like specific numbers of lengths for sides that maybe won't work to make a triangle? And how do we decide that? How do we figure out if any three sides work to make a triangle or will they not work? Okay. And to show you guys, I have a website that I'm going to pull up here. Okay, and we're going to kind of play around with this a little bit so you can kind of see, and if you can't see the screen really well, I would turn your chair right now because you're going to want to see what I'm doing up here. We have this triangle and it's got these three sides on it, okay, and you kind of see how those edges have like those little yellow circles on them. So the goal is for me to be able to move those sides, like I can click and drag them, and I want to get those yellow circles to land right on top of each other and overlap. And when I do, this is going to give me a little message up there that says like, yay, you made a triangle, okay? And then as we kind of start to play with this, we're then going to start messing with the lengths of sides. So can I make these smaller? Can I make them bigger and still make triangles? Or is there going to be like limits that we start to recognize, okay? So we're going to look at this first one. I have three sides, 7, 9, and 12. Do you guys think it's possible for me to get those two dots to connect? Yeah? Now, I will say this website can be a little finicky sometimes, so I got to be really careful about how I overlap them. But do you see how I got my message there? And that triangle kind of lit up. It's like, hey, we got those to cross. This is a triangle, all right? What do you think is going to happen if I start to like make that 7 smaller? Do you think they're still going to meet if I start to decrease that side? What should I decrease 7 to? 5? Okay, let's try 5. Do you think it's possible for me to get these two circles to touch? Yeah? What would I need to do?
5 inward.
Like this?
A little bit and then down.
Okay. Maybe I move this one maybe a little too far. And this is where it can kind of start to get real finicky. But there, look, it overlapped again. Okay, so yes, I could decrease 5, but I'm still getting a triangle here. Do you think there's a number that is too small? Should we keep decreasing it? What should we put it down to now? 2. Are these going to cross?
No.
No, it's way too short. Like there's this gap in between them, and I can try to move these sides as close, like even if I try to get them really close to the bottom, because that's probably going to get those closest, there's still that gap. Okay, so 2 is too small that I wasn't able to make a triangle. All right, what if I decrease the size of the very bottom? So like right now it's at 12. What if I decrease it down to like a 10?
Yeah,
now they'll overlap? Now it's giving me that message. They're intersecting. Can you make a triangle? So it's kind of telling me you got to move that other side so that I can get them to kind of line up. Really close. Let me try to move this one down just a smidge. There we go. We got it. Okay. Can you guys give me a new number for that 9? Can it be bigger or smaller here? 8? Will 8 still make a triangle? No? Man, they're really close though. Look how close those are. But if I zoom in, do you see how there's really a lot of space in between those numbers or those sides? Now, when I zoom out, they look pretty close. Okay, and in fact, if I like maybe bump this back up to like a 12, and if maybe I put this up to a 4, because I did this earlier, like they get really close to meeting. We had one in my first period class where they looked to the eye that they were overlapping, but it wasn't giving me my message of like, this is making a triangle. And when we zoomed in, we saw that there was like a teeny tiny little gap in between those two circles. Okay. So are you guys thinking anything about what do these two sides, the 8 and the 4, need to do in order to make a triangle? Parker? Then the red line. So right now 4 plus 8 is how much? 12. And that bottom segment is also 12. And this isn't working to make a triangle. But if we increase this up to just like the blue line up to a 5, will it work now? Because what's 5 plus 8? 13. And so I'm going to have to, move those up there. But now look, I got it to make a triangle again. Okay. What if, okay, I want to play around with this a little bit more. What if I change this to a 10 and I make both of these 5s? Is this going to work? Why does this not work again? They're equal to each other. Okay, but this is technically like I'm trying to make an isosceles triangle. We saw isosceles triangles working yesterday. What do I need to do here? I still want an isosceles triangle. What should I do to make this work? You want to decrease which one? The A. To what? Can I just go to 9? Will 9 work? Now they're intersecting. They scooted a little bit closer, but if I move these up, am I going to get a triangle? I should. Oh, I got it. There we go. Okay, because 5 plus 5 is 10. 10 is bigger than that third side still. Okay, so I'm hoping you guys kind of start to understand. If I have a base of 10 and I start to manipulate these sides, they have to be, when I add them, greater than that third side in order for it to make a triangle. So like I even just move these to 6 and 5 right now, and I make a triangle. The second, though, that I start to decrease this side to a 5 or to a 4 or to a 3, and I try to move those sides together, they're never going to cross because they're not quite long enough to touch. So let's talk about how do we look at this as far as problems that we're going to see in our notes today. Okay, so we're on this page in our packet, and we're talking about potentially given 3 side lengths of a triangle, and they are wanting us to figure out if they work or not. So what I want us to do first is just write down what we just talked about with that website. We saw that the 2 smaller sides must add to more than the third side. Okay, so I'm going to let you jot that down. So like I was saying, what they're going to do now is they're going to give us some potential side lengths. So they're going to give us 3 numbers, and we have to figure out, does this work or not? And all you have to do to figure this out is you have to look at what are the 2 smaller sides, add them together, and if they're bigger than the third side, not equal to, they have to be greater than the third side, then it works. If it's equal to or if it's less than, it's not going to work to make a triangle. Okay, so if we look at this first one, I've got 12, 17, and 12. The 2 smaller sides are the 12s. So that's really all that I'm focused on right now, is adding those 2 smaller sides together. What would be 12 plus 12? 24. Is 24 greater than 17? Yes. So this would work. This should make a triangle. What about number 2, though? Why does this one not work? Yeah, my 2 smaller sides are still the 12s, but this time I needed it to be greater than 25. It's not. 24 is not, I'm going to just draw a slash to that, not greater than 25. So this has to be a no. You guys do 3 and 4. What'd you guys say for 3? Does it work or no?
No.
They're equal. 10 plus 9 is not greater than 19. It's actually equal to 19. So that should have been a no. How about number 4?
Yes.
Yes. What are the 2 smaller sides?
4 and 11.
And that's 15. 15 is greater than 12. So yes, that works. Good. Okay. Not super hard math here, guys. We're just adding and we're trying to check and see, is it bigger than that third side? Now, the next piece here, we're still talking about sides, is they're going to give me 2 sides, and they want us to find the range of possible values that the third side could be. The reason why we have a range is because we kind of saw on that website, I can manipulate those side lengths to different numbers and have it still work. So if I had like a 12 on the bottom, I could have different side lengths on either side that would be greater than 12. Like I can add up more than 2 sets of numbers and get something that's bigger than 12. So when we look at these next couple of problems, we have to figure out what the range of values would be. Okay? So what's like the lowest limit we could have? Like what's too short? All the way up to what would be too big. That's kind of what we're trying to find. So to do this, you're going to look at the 2 numbers that they give you. And to find like the too long side, like so this would be the number where if it gets to this point, it's not going to work because one of the sides is going to be too big for the other 2. You're going to add these numbers together. So what's 8 plus 9? 17. Now to find the lower limit, so this would be a side that would be too small, you're going to subtract. And I always suggest that you start with the larger side and you subtract the smaller side. That way you're avoiding negative numbers because it doesn't make sense to have a negative number for side length. So I'm going to take 9 minus 8 and I get 1. Okay, now we're going to write this out as an inequality. So you're going to put the numbers 1 and 17 and I'm going to put an X in the middle. I'm leaving a little bit of space. You can kind of see how I wrote it like that? I need to put in these inequality signs. So remember when we were writing it up above, I was using the greater than symbol a lot. So when we're writing it out like this, what I'm trying to say is 1 would be too small. I need numbers that are bigger than 1. So I know it's going to look backwards because this looks like it's a less than sign. But if you read it the other way, if you start at X and you go towards the 1, it's saying X has to be greater than 1 because 1 would be too small. Now 17 would be too big. So we're going to put in another less than sign there. So X is saying that it has to be bigger than 1, but it has to be smaller than 17 in order for it to work in this situation. Because if you think about what we just talked about, if my third side was a 1, 8 plus the 1 would be equal to 9. That doesn't work. If the third side is 17, 8 plus 9 is 17. That doesn't work either. We can't have them be equal. It has to be greater than that third side. Okay, so this is how we're going to be writing the ranges. You guys go ahead and try that for number 6. So what'd you get when you added them?
24.
And when you subtracted?
0.
So how would you guys write the inequality here? What goes first?
0.
0. And then less than X. Perfect. That's how we want to.
2 less things.
It will always be 2 less than signs. Yep, that'll never change. Now, if you choose to write it backwards, if you write 24 first and then the 0 second, then you'd have to switch them to greater than, which is also okay. You guys can switch that around if you like that better. But yeah, that's how we're going to write it. That's how I'm going to write it anyways, with less than signs. Okay. Do you have any questions so far on what we've talked about? Feeling okay, everybody? All right. So on the last couple of problems here, they're giving us a triangle and either all the angles are filled in or all the sides are filled in. And what they want us to do is list the other set. So if you have the angles, they want you to list the sides in order from like least to greatest or greatest to least, however they specify. Now, there is a direct connection between angle measurement and side length. Yesterday, when we talked about the isosceles triangle, we saw that if I had two congruent sides, that meant that there were two congruent angles in the picture, and then one was different. Okay? That's going to happen here as well. When you look at these angles, however much the angles are is going to play in directly to how long the sides would be. So they want me to order the sides of this triangle from shortest to longest. So what I would do is, looking at this triangle, where's the smallest angle?
50.
E is at 50, right? So to write the smallest side, you need to go to the side directly across from the 50. How would you name that side with letters? FD. So here's how I'm going to write it out. I'm going to use S for shortest. I'm going to write FD. FD is the shortest side because it's across from the smallest angle. So if 50 was the smallest, what's the next biggest angle? 60. So what's across from that? ED. And then what would be the biggest angle? D. And across from that would be EF. Or FE. Yeah. Do you guys think it matters what order we're putting those letters in? No, if you said DF, DE, FE, either one of those would work as well if you just kind of do a little switcheroo, because you're still naming those sides. And something that I want you guys to maybe recognize is whatever angle you're working with. So like on that last one, we were working with angle D because that was the biggest angle. The side across it was the other two letters E and F. So if you're saying that D is the biggest angle, D should not show up in the name of the side, because then that means you're using the wrong side. All right, so how about for 8? What would be the smallest angle? What would be the smallest side? TR. Again, if you need to draw those angle or those arrows like I was doing to just kind of keep track of what you've listed, you can do that. Mark up your pictures if you need to. Okay, so TR was the smallest. What would go in the middle?
TS.
Good, TS. And then the longest side? SR. Good. Everyone see how we're doing that? Okay. Just again, because I had a couple of confused looks at me there. 50 is the smallest angle. So the side that's across from 50 is going to be the smallest side. That's why I'm drawing those arrows. I'm just going directly across from that angle to get to that side. That's why we're saying TR is the shortest, because I'm just naming that. Then I'm going to go to the next biggest, which is 62. And again, I'm going to draw an arrow. So 62 across is that side TS. That's why we're saying that's the middle. And then the largest angle in my picture is 68. And so we're going to go across from that, and we get to RS, or SR is how we named it. Okay? Hopefully that clears it up a little bit. Draw those arrows in there if you need to, because it really does help you see the connection of the angle to the side. Because I know it can get really confusing. There's a lot of letters being thrown around, and we're trying to list sides, and they're giving you nothing about the sides. So use those arrows and that marking to help you out. Now we're going to do the same thing down here, but they're giving you side length, and they want you to list out the angles. So we're going to do the exact same thing, but instead I want you to list out angles now. So if you guys look at number 9, what's the smallest side? 10 is the smallest side. So again, I'm going to draw those arrows in here. I'm going to just connect it directly across. So that angle X is directly across from the 10. So that means X has to be the smallest. And I'm just going to list them out this time, like in order. What's the next biggest side? 15. So if I start at 15 and I draw an arrow up to the angle that's directly across from it, where am I at? Z. And then the last one would have to be angle Y. What about number 10? Logan? Yeah, tell me what you're thinking.
See if it's thinking C and C, both, A and C both equal one of the tens. So.
Right. So we're looking at this and we're recognizing, okay, there's a 10 here and there's a 10 here. What kind of triangle is this? This is an isosceles triangle, okay? So the 10s are the same. So we're going to go directly across from those. And that's what he was talking about. Now, because they're both across from 10, that means that those two angles should be equal to each other. So we could consider them both the smallest. So how I'm going to write that is angle A and angle C. Because it's really probably not right to say angle A, comma, angle C, since they're the same amount. We have to kind of keep them grouped. And then what would that leave us with for the biggest? Angle B. And that makes sense because it's across from 15. 15 is larger than 10. Okay, how about 11? What would be the smallest? 8.9, so the angle would be H. Next, angle G, because that's across from 10.1. And last, angle F. Any questions on listing out sides or angles like that? All right.